So you might be wondering why, for this video, we have an operation on a set that gets its own video, whereas all the other ones were in the same video. And that's because this operation, the Cartesian product, is a beast of its own. And it has thrown so many people off that I think it deserves its own separate contained entity. Now, the Cartesian product requires you to remember one thing from grade school. Let's just say back in yonder days when you had a graph and you just selected a point on a graph. This was your x and this was your y, and we had the xy plane. This point, say it was 1, 1. What did we call this? We called this an ordered pair. And it's important that we called it an ordered pair because it's not a set. Because a set has no order. The set 1, 2 and the set 2, 1 are equal to each other. But if we were to do an ordered pair 1, 2, that is not equal to the ordered pair 2, 1. An ordered pair is a collection that contains order. So when we had these points on a plane, we understood that the first one was x and the second one was y. Now, the Cartesian product is going to be creating a set just as all the other operations were creating sets. However, it's not going to be creating a set of elements. It's going to be creating a set of ordered pairs, which in their own right will contain elements. But it's important to understand what we're doing. Now, this set, a Cartesian product, it's written A cross B, where the x is a cross. Or it looks like A times B with that old ugly multiplication notation. And what you do is you create an ordered pair of every single element inside of A and B. Now, since A is first, order also matters in the Cartesian product. A is first. Now, since order matters in ordered pairs, it's going to matter here. So we want to create a set of all ordered pairs of elements in A and B. So what would that look like? That's going to be 1 and 3, 1 and 4, 2 and 3, 2 and 4. Now, look at this. We just took 1 and we made an ordered pair 1 and 3. Then we made an ordered pair 1 and 4, and then 2 and 3, and then 2 and 4. So we make all possible ordered pairs of elements in A with elements in B. And hopefully that's not too tough to understand. And also know that 1 came first and 2 came first because A came first in the order. So I'm going to quickly write out B cross A. And this is what we get. We get the same thing, but just with orders reversed. Because remember, ordered pairs, order matters. And you are creating every possible combination. So if there was a third element inside of here, we would have to add that element with 3 and 4. So like say, for example, 5 was inside of A. Right? Then A cross B would have the added items 5 and 3, and then 5 and 4. And then this B cross A would also have 3 and 5 and 4 and 5. You're just using this to create ordered pairs. So it might seem a little strange to have a set containing, a collection of numbers, but that's allowed, and we can do it. And then, if we go back to those yonder middle school days, we can see that this plane that we had and these ordered pairs that we had, well, funny enough, that was just the Cartesian product of R cross R. Right? Because if we're taking R cross R, that's all possible points, like 0.5, comma 0.5. Or, negative pi, comma 1, negative 1, like this one. So a Cartesian product, all it's for is just creating these collections of ordered pairs. And that's it. That's everything on set operations. In the next video, we'll go over some examples just to help reinforce these operations that we have.